The lesson outcome for this video is I can add and subtract rational expressions with like unfactored denominators. So this is very similar to the previous lesson where we added and subtracted rational expressions, but this time we need to pay attention to the fact that our denominator, although they are like denominators, they are common, they are the same, after we do our addition or subtraction, we are going to need to factor the denominator and then simplify. So really not very different from the previous lesson, but we're going to go ahead and practice a few of these in this video. So first things first, we need to, again, pay very close attention to whether it's addition or subtraction. In this case, it is subtraction. And I mentioned this in the previous video, we have to be very careful because that means the subtraction sign needs to be given to the n as well as to the plus 3 when we add or actually subtract these two fractions. So we know that the denominators are like denominators, so we have an LCD, or a least common denominator. That's a term we're going to use a lot in Algebra 2. The LCD is the least common denominator, and right now we do have a common denominator, so we're good to go with that. And we can go ahead and write n squared plus 7n plus 6 right there. And now we are going to simply subtract across the top, or the numerators. 3n plus 15 minus n minus 3 is what we want to write. And I would write that all out as to not make mistakes with our combining terms with that subtraction sign. So 3n plus 15 minus n minus 3. Alright, so now, just like in the previous video, we're going to combine our like terms. We have 3n and a negative n, or negative 1n. That'll give us 2n. And we have positive 15 and a negative 3, and that will give us plus 12. In the denominator, we still have n squared plus 7n plus 6. Now what I think it's kind of important to point out to you is that, and I'm going to use a rectangle to kind of cover some stuff up here. I'm going to go ahead and cover all this up for a minute. None of that actually matters anymore because we did our subtraction of our two fractions and now we have arrived at this fraction right here. So we need to simplify this rational expression by using the same skills we've done in the previous lessons. In the numerator, we can factor out a common factor, a GCF of 2, and we'll be left with n plus, and then we have 6 when we factor 2 out of 12. In the denominator, we have a quadratic expression with 3 terms, a trinomial, and the leading coefficient is 1, so we know we can put our 2 sets of parentheses down right away. We can write our C term of 6 off to the side, and find the factors of 6, 1 times 6, and 2 times 3, and which of these adds up to our middle term of positive 7, well, the 1 and the 6 do. So we're going to have n plus 1 and n plus 6. Now we can cancel out any common factors we have in the numerator and in the denominator. We have an n plus 6 right here and an n plus 6 right here, so 1 in the numerator and 1 in the denominator. And then we have no other common factors. So our final, most simplified answer is 2, 2 over n plus 1. Okay, so if we kind of get rid of this little rectangle now, we do have the whole entire problem shown, and again, this is our answer. Alright, so let's try this next example. We have 2n minus 3 over n squared minus 8n plus 12, plus n minus 1 over n squared minus 8n plus 12. Notice this is an addition problem. We're going to be adding across the numerators as long as we have a common denominator. We do have a common denominator. So that common denominator stays here, n squared minus 8n plus 12. And in the numerator we have 2n minus 3. And again, be careful, if this was subtraction, we'd have to distribute that, but it's just plus, which still means we distribute this, but we're going to add n, and then we're going to add negative 1, which just means we can say plus n and then minus 1. All right, combining like terms, we have 2n and another n here. That makes 3n. And then we have the minus 3 and the minus 1, so negative 4. And in the denominator we have n squared minus 8n plus 12. All right, so just like in the last example, I'll just kind of cover this up. Don't worry about any of that right now. We need to simplify this rational expression. The numerator is simplified as far as possible. 3n minus 4, there's no GCF. It's not quadratic, not a difference of squares type of quadratic. But the denominator we can factor. It's a quadratic trinomial with a leading coefficient of 1. We'll go ahead and put our two sets of parentheses down and put the c term off to the side. So we have 12. 1 times 12 is 12, and 2 times 6 is 12, and 3 times 4 is 12. Which of these adds up to negative 8n? Well, none of them right now add up to negative 8. The 2 and the 6 add up to positive 8. We realize with that positive 8, if we make both of these negatives, that will be negative 8, yet we'll still multiply to give us positive 12. So we have n minus 2 and n minus 6. Now, we cancel out any common factors in the numerator and in the denominator. So sometimes, guess what? Nothing can cancel out. 3n minus 4 is a binomial factor, and we do not have that same binomial factor here. You might want to, therefore, try to cancel out other parts, but remember, we can only cancel factors, we can't cancel terms. Can't cancel a 4 with anything down here, can't cancel a 3 or an n down here, because this is one factor. So our final answer is 3n minus 4 over n minus 2, n minus 6. Again, it's okay if things don't cancel out. Still our final answer. Okay, so we have one last example for this lesson. We're back to subtraction. Always pay attention to the fact that if it's subtraction, we have to be very careful to give that subtraction sign to both terms in the numerator of the next fraction. We do have a common denominator. Should have paid attention to that first, I suppose. So we are ready to add, or in this case, subtract our fractions. We can leave our common denominator of 4n squared plus 20n. In the numerator, we have n plus 5 minus n, and then watch out here, it's a minus a negative 5. What's minus a negative 5? Well, that will be plus 5. All right, so combining like terms, we have an n and a negative n. Well, those create 0 when you add them together, 0. So we're not going to use any n terms. And we've got a 5 and another positive 5. That makes 10. So we have 10 in the numerator and 4n squared plus 20n in the denominator. Again, ignoring all of this, all we're going to do is focus on this rational expression right here. We can't do anything with the 10 in the numerator, nothing to factor out because it's just a single monomial term. So here we have 4n squared plus 20n. Hopefully you notice we can factor out a GCF of 4, and a GCF will also contain n because there's an n in both terms. Okay, 4 divided by 4 will become 1, which we wouldn't need here. N squared, if I factor out an n, I'm left with n plus 20 divided by 4 is 5, and then n factored out when we no more n's are here, so this will be a 5. At this point, there is a small bit of canceling out we can do because there's a common factor in the numerator and the denominator. And that common factor is that 10 is divisible by 2, it has a factor of 2, and 4 also has a factor of 2. So if I divide this by 2, I get 5, and if I divide this by 2, I get 2. Our final answer for this one is 5 over 2n times n plus 5. Again, it's very important to remember you can't cancel this 5 with this one because 5 here is a term in a binomial, and therefore this is our final answer.